Welcome to the Cosmic Savannah with Dr. Tshiamiso Makwela,
Dr. Jacinta Delhaize,
and Dr. Daniel Cunnama. Each episode, we'll be giving you a behind-the-scenes look at world-class astronomy and astrophysics happening under African skies.
Let us introduce you to the people involved, the technology we use, the exciting work we do, and the fascinating discoveries we make.
Sit back and relax as we take you on a safari through the skies. Hi everyone, welcome to today's episode.
Hello, Jacinta.
Hi everyone.
Today we'll be speaking to Dr. Eli Kasai from the University of Namibia, and I spoke to Eli recently about how he set up the entire astronomy department at the University of Namibia. No big deal or anything.
Yeah, so Eli is a Namibian, and he studied his astronomy down here in Cape Town at the NASP, the National Astrophysics and Space Science Program, which we've talked about previously. And now he's gone back and started up a department in Namibia.
Yeah, and Eli is one of those special cases, right, where people actually leave their workplaces to come and study astronomy. I mean, who does that?
Yeah, left a well-paying job in industry to follow his passion. So good on him. It's a really inspiring story, so I hope you'll enjoy it. Eli also works on blazars, which are big, well, he'll explain, but basically big supermassive black holes that are eating stuff and burping and...
Eating stuff and burping.
Yeah.
Things I never thought I'd hear in astronomy.
And so he tells us all about how he uses South Africa's SALT telescope to study those, and also the Cherenkov Telescope Array.
Yeah, so a gamma ray telescope. I mean, those are really cool. I dig them. Basically looking at the cascade as a gamma ray hits the atmosphere, it sort of triggers a whole lot of high energy particles, which we can look at and then reconstruct where the gamma ray came from, because the gamma ray itself doesn't make it through our atmosphere just as well. Otherwise, we wouldn't be here. But again, Eli can talk a little bit more about that.
Yeah, it's super cool. I don't really understand anything about it, but Eli explained it really well.
That's why we're here, everyone.
Yeah.
So without wasting any time, let's get into the interview with Eli Kasai.
With us now is Dr. Eli Kasai from the University of Namibia. Welcome to the Cosmic Savannah, Eli.
Hi, Jacinta. I'm glad to be here.
We're glad to have you as well. Tell our listeners a little bit about who you are, where you're from, what you do.
Right. I am originally from northern Namibia. I came down to Windhoek to come and do university after finishing school in northern Namibia. I was specifically interested in doing astrophysics, but at the time that was not one of the options that I could do at the University of Namibia, so I ended up specializing in mathematics and physics. It was a double major degree. So I was fortunate to actually secure a scholarship from NamPower, the electricity supply company in Namibia. They funded me to do the 4-year program, and then when I graduated after the 4 years, I was obliged to work for them. It was one of the conditions of the bursary. Yeah, so I did that it was supposed to be for 1 year, but then I thought I could still work for longer, and I continued working for the next 5 years. And then I applied for a scholarship to the National Astrophysics and Space Science Program in South Africa, and I got that from the University of Cape Town. So then I resigned from my job, came to pursue astrophysics and space science studies at the University of Cape Town. Fast forward to the present, I'm now an astronomer, optical astronomer. That's what my PhD training was about, and I'm currently a senior lecturer at the University of Namibia, and I'm the founding head of department for the new department now called Department of Physics, Chemistry, and Material Science. I did that for 2.5 years. I've recently stepped down from that.
Wow, what a massive achievement. Congratulations.
Oh, thank you. Thank you very much.
Opening a university department, that's not something you hear every day.
I suppose so.
Okay, we're going to dive into that. Okay, so the part that you fast forwarded, what happened in there? So you came to South Africa to study astronomy, and then how did you end up back in Namibia and starting a new department in university? Talk us through that process.
Right. I was excited about astrophysics and space studies and just, I used to follow this history channel on DSTV back then, which had all these documentaries about space sciences, black holes, stars, galaxies.
All the cool stuff.
All the cool stuff, yeah. So that really had me going, oh my goodness, I want to go and do this. But before watching that sort of just enhanced the interest for me, because already when I was in high school, I was passionate about wanting to study Newton's laws, Einstein's general relativity, and the whole concept about day and night and the speed with which the Earth revolves around the sun. All these things were mind-blowing for me. So then when I watched these documentaries, it even made things even more exciting for me. So that's what prompted me to apply for the scholarship. And I got accepted, and then I did honors. It was not easy because I had not been in school for like a few years. I've been out of school for like 5 years, and I was sitting, like I was the oldest in the class, and my classmates were just, making things look so easy, and I was really battling, but I had to spend quite a lot of time, go through the work and everything. I would really come up with excuses not to go to parties or to the movies because I needed to work. I'm just no, I'm not feeling well, But then eventually it all came back to me after 6 months. So then I finished the honors and then started the master's. And I wasn't sure I needed to do PhD when I came. I really just came for the fun of it. I thought, let me go study, these things that blow my mind so much, so I have a more professional understanding. And then upon being among the community and seeing how my supervisors and our mentors and all of these people would give their talks, the level of professionalism that came with that, I was just like, oh no, but I need to study more, because now at the level I am, I'm not able to give a talk in the way, that my supervisor does or the professionals do. So that led to me ending up doing a PhD, which led to me becoming a professional speaker as well. And so then I figured, we had a lot of astronomers on the African continent, but then I figured in South Africa, there were quite a reasonable amount already, and there was none in Namibia.
Yeah.
So I just felt I needed to go back home, and I also just needed to go back to family and everything. And that's how I ended up back in Namibia at the University of Namibia to start, astronomy activities there. When I went back, I found a colleague who the university had employed 3 years before I went back. I went back in 2016, middle of 2016. I found Professor Michael Barkes there from Germany and Dr. Rian Steenkamp, who did more computational physics, but he was really one of my mentors when I was doing my undergrad in me following or developing my passion to do astrophysics. So I found the two of them back there, and we started working together to really create a community there and a group, and it's been great. It's been great.
Yeah, gosh, that's amazing. You really followed your passion.
Yes.
Wow. And you took a risk, you left this presumably well-paying job in industry and came to study astronomy.
I know, right?
Wow.
Those times when I would really I'm struggling, things are just so difficult to understand. And so when we were doing the coursework aspect of the program, there were times that things were just so difficult. And those moments would make me think, oh, why did I quit my job? It was a good paying job. But fast forward to today, I don't actually regret anything. This was the best path for me to follow.
Right. Oh, that's great.
So,
I'm so glad to hear you say that, because, you never know, right? You don't know what you're going to end up in or get into. And for you to not regret it and to say it was the best thing and to have taken that knowledge back to Namibia, I think is so special.
Yeah. I'm telling you, I'm meeting all these great people that are just so, knowledgeable in what they do. The last decade, the early part of it, that was quite a transformational era for me, just interacting with all these people and traveling to different parts of the world and meeting great people like yourselves. We met in Japan.
Yes, we did.
For the first time. That was all because of being in this field.
Yeah.
It's just been an amazing journey, really.
Yeah. I think it was early 2018, maybe.
It was. It was.
Cool. I remember meeting you there and being like, oh. So I knew that I was just about to start a postdoc here in South Africa, and I was like, now I'm really excited. The people there are really cool, in the SKA partner countries. So that's really exciting.
Right.
All right. So, all right. There must have been, surely that's very challenging, though, to come out of a PhD and then almost immediately go back home and try and have your own students when you've just been a student and to start a department? Like, how was that?
It was quite challenging in the beginning because you know how it works in academia. You basically become member of faculty, and with that comes teaching, and that's something that I was not used to. So I spent quite a lot of time developing notes for the courses that I had to teach. And I must mention that actually when I returned to Namibia, I was not done with a PhD.
Right.
So what was happening was I took up this full-time job. And then during the day, I'm doing the teaching and the community service and all else that we are expected to do as academics. And then at night, I'm writing up the PhD. So I was done with all the analysis that I needed to do, but I was still busy writing up.
Oh my goodness. And writing is so hard. It takes so long.
Writing is very hard. Like you have no idea what you're going to write about. You just have to sit in front of that computer and start writing. And yeah, eventually I pulled through and graduated the next year.
Wow. Congratulations. That's a really big achievement.
Yes. So when we met in Japan in early 2018, I had just graduated.
Wow, really?
In December. I graduated that December. You know, we met, I think, around March somewhere. So I had graduated 3 months ago, you know.
From which university was it?
From the University of Cape Town.
Oh, from the UCT. Oh,
yeah,
cool.
That's right. Yeah.
All right. So you've done your PhD, you've gone back to Namibia, you've started a new department, you've become HOD, and then you've stepped down for that, let that roll, and now you're doing more research. What's going on in Namibia with astronomy? What's happening there?
Right. The interesting astronomy project at the moment for us is the African Millimetre Telescope that we are busy with the groundwork to build. So the idea is to build this telescope on the Gamsberg Mountain, one of the pristine sites for astronomy in Namibia.
It's kind of like Table Mountain in Namibia, right?
Yeah.
It's flat at the top.
Yeah, it's flat at the top. I think it's a site that would really attract more astronomy projects in the future if we manage to develop it very well. So that is the one thing. And then I'm also the principal investigator for a redshift determination project where I take spectra of blazars with the Southern African Large Telescope to measure their redshifts.
Okay, there's quite a few terms in there for our listeners, so let's just break that down. So first of all, we talked about the African Millimetre Telescope. That's something different. And now you're talking about the sort of the science that you do, which is with SALT, the Southern African Large Telescope, big optical telescope here in South Africa. And you're the PI, meaning the principal investigator of a project. And it's trying to find the real distances to galaxies.
That's right. So basically the redshift information translates into distance information that basically tells us how far away the object that we are looking at is from us here on Earth. And that's very important because the spectral energy distribution, I'll break that down, that we try to study and to understand the behavior of these particular objects that we study is dependent on the distance information. How much power or flux
or brightness
that this object sends to us across all the different bands of the electromagnetic spectrum is dependent on the distance information.
Okay, so that's sort of like when you have a flashlight, like let's say the flashlight on your mobile phone, and you hold it really close to your eye, it looks really, really bright. Right. But then if you move it further away, it's releasing the same amount of light, but it looks dimmer to you, right? And so that's why if we just see a certain amount of light coming from some galaxy, we don't know how bright it is in reality. We can only see how bright it is to us, how bright it appears to us.
Right.
But if we know how far away it is, and we know how dim we're seeing it, we can figure out how bright it is.
Exactly.
In reality.
Right, yes, that's correct. Correct.
Okay, so then the galaxies that you're looking at, they're something called blazars.
Yes.
So what's a blazar?
So a blazar is, let me start by quickly just defining one or two terms before I define that. So in the centers of galaxies, and galaxies are these, groupings of stars containing, billions of stars, the bigger ones. So in the centers of each one of those galaxies is what we call a supermassive black hole. So basically galaxies are home to supermassive black holes. It's a huge monsters of gravitationally strong objects. Pretty sure our listeners have heard of black holes.
Yeah, I'm sure they've heard of black holes and supermassive black holes.
Yes, that's right. Now, some of these black holes are active, others are not so active. So blazars are a type of active black holes in which the radiation that they send out as they accrete or as
the black hole's eating
As the
stuff.
black hole is eating, basically the word accreting, that's basically what it means. Thank you, Jacinta. As the black hole eats, because these active black holes are quite hungry, very hungry all the time. So as they eat, they give out radiation. It's like they're burping, right?
Yeah, that's a good. So a blazar is a supermassive black hole burp, basically.
Yeah, exactly.
I like that.
And the burp, the burp is this jets that sort of shoots at opposite ends, as they burp, if you like. So for the case of a blazar, the radiation, the burping effect, that is directed at us.
Okay.
So it's along our line of sight.
Yeah.
To the black hole, to the supermassive black hole. Other, eating black holes, when they burp, the radiation does not necessarily come to us. It points elsewhere, and we have a different name for those.
Okay, so the black hole burp can go out in any direction,
Right.
and blazars are the one that just happen to come directly towards us.
Yes, exactly.
Okay.
Very well put. Yeah, so the ones in which the burping effect coincide with our instrument, as we look at them, those are the blazars. And these are the interesting black holes for the Cherenkov Telescope Array that will be built in the near future, because there's just so many underlying properties and physics that we don't understand.
Okay.
So the research that I'm doing with the Southern African Large Telescope is to measure the distance to basically understand the real brightness, the real burping that they give out, because what you said earlier, if they are far away, we don't know their intrinsic or the real brightness they have. But if we can nail the distance, then we know, okay, so you are actually doing this much burping.
Okay, I feel like this episode's going to be called Burping Black Holes.
That's a good one.
So, all right, so you're trying to find out how big is the black hole burp.
That's right. Yeah, exactly.
I like that.
Yeah.
Okay, cool. And now you've mentioned the Cherenkov Telescope Array, the
Right.
CTA. What is that?
So this is the next generation of ground-based telescope that will observe the Cherenkov light. Okay. So this is the light that gamma rays that originate from violent processes in the universe, the very energetic processes in the universe. The Cherenkov light is what they generate in the sky. Once these gamma rays enter our atmosphere, they create what are called air showers.
Air showers?
Yes.
Okay.
So these air showers is what a telescope like the Cherenkov Telescope Array would observe. And these air showers, they only actually last for nanoseconds.
Right.
They basically, you can only observe them at nanoseconds timescales.
Okay.
So the Cherenkov telescope is in a way an optical telescope because it observes this blue light that is very short-lived. The technology is so amazing that it can actually photograph that effect at nanosecond timescales.
Wow. Okay, that's crazy. So I'm going to take a guess here. Something is causing some high energy particle that we call a cosmic ray to create an air shower, which this telescope can pick up.
Right.
And it's only like a nanosecond long.
Yeah.
And then the thing that's causing this initial cosmic ray particle that is causing the shower, let me guess that's a blazar.
Yes.
Or one thing that can cause
so
it.
blazar is shooting out all these gamma rays
Okay.
that upon reaching, our atmosphere, they then cause these air showers, a part of which is blue Cherenkov light. They cause other things as well. They generate muons and they generate all other
weird
kinds of
particles.
in the sky. And in that is basically also the Cherenkov light, as you correctly summarized it. And from observing a number of those with different telescopes, we can then reconstruct the direction of the gamma ray that caused the shower in the atmosphere. That tells us the amount of gamma rays that actually triggered that shower after the reconstruction. And it also tells us the direction from where the gamma ray came from.
Oh, you can tell the direction?
Yes.
I thought that would be really hard because the shower surely goes in all of these different directions.
It does, but there's a clever way that,
I'm sure
when we
is.
combine, there's always these clever ways in
always clever
astrophysics,
ways.
in our observations with astronomical facilities.
Awesome.
There's always a clever way that we bring all these puzzles together and, paint the real picture of what we're trying to understand. Yeah.
All right, so the Cherenkov Telescope Array, I happen to know that that's going to be built in Chile and La Palma.
That's right.
But that's going to be the successor of a telescope called HESS that's already in Namibia, right?
That's right.
So tell us a little bit about HESS.
So the HESS telescopes were built for the same mechanism that I described about observing the Cherenkov light, the Cherenkov radiation, this blue light that, the flashes which last for nanoseconds timescales. These were built in the early 2000s, actually 2002. That's when the first 4 were built. And then 10 years later, a bigger one was added to increase the energy range that the whole observatory could go up to, pick up more fainter sources as well. And the mechanism is the same. It's basically to detect the Cherenkov radiation and thereby reconstruct the path of the gamma rays that actually cause these air showers in the sky and study high energy gamma ray sources in the universe.
Sorry, yeah, that's also been a very successful telescope, hasn't it?
It has been. It actually won a number of prizes, the Bruno Rossi Prize in the US and the Descartes Prize in Europe. And the gamma ray sky now is very well known and very well catalogued because of the HESS telescopes.
Yeah, that's cool. I mean, gamma rays are such high energy, a type of light, and so we can see things in space with it, but it's because it's so high energy, it's quite hard to capture. So this is one of the really cool ways that people have figured out how to observe it from the ground. From the Earth.
Pretty much.
Yeah, that's cool. And Namibia is right at the center of it.
Yeah, pretty much. Yeah,
so speaking of being at the center of things, tell us more about the AMT, the African Millimetre Telescope.
Right. Before I tell you about that, I was just going to add that, so the HESS telescopes are not the only type of telescopes that did that kind of science. The other ones called MAGIC and Veritas and other ones. So I don't want to discredit, their contributions to resolving sources in the sky. Those ones they managed to observe to date. So yes, the African Millimetre Telescope. So this one observes in a completely different energy band of the electromagnetic spectrum, lower frequency, not as low as the Meerkat telescopes.
Yeah, not as low as radio.
Yes.
How low can you go?
This is more at that millimeter wavelength. So we're very excited about the African Millimetre Telescope because it adds a different angle to, the radio observations that Southern Africa has been heavily investing in over the many years. So this is sort of an exciting addition to that because it's a high frequency type of radio observations. So we expect this to be built in the next few years, probably in 3 to 5 years from now. We're still, busy with the groundwork for that, and hopefully things can go according to plan, and we can have it built on the Gamsberg Mountain.
Yeah,
soon.
These things take such a long time to plan and build, like decades.
Know, right?
And you, I think it was you yesterday when we were having a discussion, coined the term astropolitics.
Yes.
Which we don't need to discuss any further.
That's
but
a
I can
term
imagine.
that I've come to learn recently, and I cracked it when I heard it for the first time. I'm used at it. Yeah.
I love it. Okay, and then the AMT, what is that going to be able to do? Is that going to be part of the Event Horizon Telescope?
Oh, yes, that's right. Yeah, so it's being built to sort of fill a gap in the existing network of the Event Horizon telescopes, where we don't have a single one on the African continent. And that introduces limitations to the existing network of the Event Horizon telescopes. So the idea there is...
And that was, of course, the massive worldwide telescope that created the first image of an actual black hole, right?
That's right. Yep. So now 2 and counting. So more black holes will be observed. Recently we observed our own. Right at the center.
Sagittarius A star, our friendly neighborhood
That's
black
right.
hole.
And in Namibia, we see it right above us. Yeah,
That's
the
cool.
latitude is just so ideal for
Wow.
Namibia, that where the AMT will be built. If you stand there in the middle of winter, which is June, July, the Sagittarius A star is right above you.
You just look straight up.
Yeah.
Wow.
Right there staring at you saying, hello. So the idea with the addition of the African Millimetre Telescope to the network now is that it will allow the creation of movies. So, a black hole be caught with its pants down, basically, in action. So the idea is to see gas going around the black hole as it eats and accretes and so forth.
Well, that would definitely be cool.
That would be awesome.
Yeah.
So it's worth every penny that's going into that, because that would be, the holy grail, basically.
And I've heard that there's quite a lot of effort going into sort of sharing this with the public in Namibia as well.
Oh, yes, that's right. Yeah, the mobile planetarium. So we've been fortunate. Our partners in this project from the Netherlands, Radboud University, they brought a mobile planetarium to Namibia because they have a similar concept there in the Netherlands. So we've been able to go around and just have planetarium shows. Our UNAM students, postgrad students, are heavily involved in this, in conducting these shows. And quite exciting for us, recently we actually got an award.
Wow, cool.
We got a grant. No, not a grant, but sponsorship. We got sponsorship from one of the local banks. So they gave us about $500,000 rand to do more planetarium shows. So this means that actually we can recruit more students to carry out these shows, and we can have more students trained to conduct these shows, so we can reach out more students. There's quite a number of other sponsors that have come on board, like one of the local airlines called Fly Namibia also afforded us 2 flights for our team to go anywhere.
Cool.
To areas that might be too far. So they can actually be flown to any school that's too far away from Windhoek, where the planetarium is based. And it's quite exciting. It's quite an exciting time for us. So I think that we can, reach a lot of kids that we can then train, to become future astronomers. And not only astronomers, but also future scientists, because we need more scientists in Namibia for other projects as well.
Well, it sounds like it's all happening in Namibia. Everything's up and coming. It's very exciting. So thank you very much for all the efforts you've put in, and the way you're helping to grow astronomy in Namibia. It's a massive thing. If any of those students or children or interested people out there are listening to this right now, do you have any messages for them?
Certainly, we would like to see a lot of young people following careers in STEM, because we really want to train as many scientists as we can. We're looking for astronomer capacity is something that we've been constrained with. We don't have the critical mass. Like if I'm to be run by a bus tomorrow, there's no one, succeeding me at the moment. So we want to change that. We need more astronomers, but not only that, we also need scientists and engineers, because we also have bigger projects coming up like green hydrogen economy. Namibia is heavily invested in that. It's going to need its own scientists. And then there's oil and gas, even though, it's not a popular route to go because of fossil fuels type of energies or not. But I think, in general, I would really encourage, everyone listening out there, especially if you are in Namibia or in Africa, to take your STEM subjects very seriously, because we need quite a lot of scientists and engineers and astronomers on the African continent.
You have to take your math subjects.
Yes.
And how can people contact you or get more information about this?
I am at the University of Namibia, so I can be reached there. I can share my contact details if that's necessary.
Cool. We can put that on our website.
Yeah, I can be contacted at ekasai@unam.na.
Thanks very much, Eli, for speaking with us today, and good luck for the rest of your work and your career.
Yeah, thank you, Jacinta. It was a pleasure talking to you. Bye.
Bye now.
Very cool news about the planetarium and the funding they've got. I recently met one of his colleagues as well, who's been working on the planetarium there. They've done an incredible job, not only just to raise funds, but they've got, a couple of full-time people working now on the outreach project, taking the planetarium around and just accessing places that had never really been exposed to astronomy before. And I think that, these are the kind of things we want to do. Eli started a department there. He's like astronomy needs to grow in Namibia. They've got these telescopes and the African Millimetre Telescope, which is going to come. So they want to build the astronomy community there.
Fantastic.
Yeah.
Getting out there with the planetarium is a great way to get people excited and into it.
I think it's worth mentioning that 2 of the people that are working with Eli and the mobile planetarium actually came to South Africa last year and joined the African Regional Meeting on Astronomy for Education.
Oh, this is the meeting that you run.
Yeah.
Oh, cool.
And, they did share some of, the work that they do, the planetarium, taking it in different places. It's not only fascinating for the kids to know about the stars, but it also just offers them an opportunity to think about other careers beyond the ones that they've been exposed to already.
Definitely.
Yeah, thanks once again, Jacinta, for speaking to Eli. And then I suppose we should check in. How are you guys?
Tired, to be honest.
What have you been up to?
I have been writing a very large research grant, my first one, for a 3-year research grant, which is very unlikely to be successful, but you got to be in it to win it.
Yeah, exactly.
So, it's very, very competitive. But the main point was to have this sort of proposal written so that now I can kind of copy paste
Next time.
for other, for
Copy,
other
paste,
sources.
and improve.
Of course. Put
And
into
edit the-
ChatGPT.
This one didn't go through ChatGPT.
No comment.
This will come out after the grant
Oh,
application.
in that case.
Well, actually, it might not be.
Yeah, but lacking a little bit of sleep, but that's okay. And other than that, doing well. Learning how to be a dog mum. It has its challenges. I'm loving it, but definitely has its challenges without going into too much detail.
Fun times.
How are you?
I'm fine. I'm good. A little bit tired, maybe because of the winters coming through.
Today's quite a wintry day.
Yeah, it was just so difficult getting out of bed. Like I was awake, but just actually getting up and like getting out of bed was just a challenge. Other than that, I'm okay. I think it's a bit of a chilled week-ish for me because I'm just focusing on writing. So that's a bit better than trying to answer emails sometimes.
Very nice.
I know. How are you, Dad?
I've got a meeting-filled week. I don't know how that happened. But yeah, otherwise I'm doing okay. I have different challenges. I went running in the rain this morning, but that was also difficult.
Well done.
But when you say running, you mean like a marathon, basically?
No, I mean, 16 kilometers.
Just
my
16
word.
kilometres to wake up.
Yeah, I'm training hard at the moment. I've got a big race coming up in a few weeks,
Cool.
which is nice.
Which one?
Is it the comrades?
The comrade.
Wow.
To our listeners who don't understand, what is the comrades?
Well, that's your thing, Dad.
Wow. It's a big
Because
long
I know it's
ultra-marathon.
like 80 kilometers, right?
Yeah, it's almost 90.
That's
a big
ridiculous.
ultra marathon that happens
Wow.
every year in South Africa. It's normalized in South Africa for those of you who aren't South African. This is something that every runner does because that's normal.
I feel like everyone from Cape Town, I don't know about the rest of South Africa, is just a marathon runner, just a cheeky casual marathon
Well,
runner.
that's it. I mean, running normal marathons like 42Ks is not deemed like
Unusual.
Very, very impressive. It's like, well, what else did you do on Saturday morning?
Okay.
Anyway, so that's coming up in a few weeks. Hopefully all goes well. That's my hobby.
We'll be cheering for you all the way from Cape Town in our warm bed.
Yeah, it starts at like 5:30, and it's always a challenge to get people to wake up just to watch it on TV. Oh, that's the other thing; it's televised on live television.
That's how I know
across
about
the
it. Oh, really?
country.
There you go.
For like the last 50 years.
Okay. I definitely would probably be in bed until after it's
Yeah.
finished, but
Actually, one of my uncles used to run the marathons.
Oh, wow.
So we used to actually wake up and watch all the marathons. So the Soweto marathon actually goes across my grandmother's house. So we'll be watching on TV and just like go outside to see our favorite runner. Yeah.
That's why comrades is in my blood. We're talking far too much about running. Sorry.
Yep, sorry.
it's an astronomy podcast, but that's all right. Astronomers are allowed to have other hobbies.
I grew up like in the town where it sort of starts and ends sometimes.
Oh, cool.
So we also used to just sit on the side of the road with a breakfast and cook breakfast and watch for hours and then runners coming past. All right, I think that's probably quite enough running.
Yeah. And
thank-
probably it for today.
I could go on, but I won't.
Thanks very much for listening, and we hope you'll join us again for the next episode of the Cosmic Savannah.
You can visit our website, thecosmicsavannah.com, where we'll have the transcript, links, pictures, and other stuff related to today's episode.
You can follow us on X, Facebook, and Instagram at Cosmic Savannah. That's Savannah spelled Savannah. And you can also find us on YouTube, where audio-only episodes are uploaded with closed captions, which can be auto-translated into many different languages, including Afrikaans, isiXhosa, and isiZulu.
Special thanks to our guest, Dr. Eli Kasai from the University of Namibia, for speaking with us today.
Thanks to our podcast manager, Francois Camphor, our social media manager, Sumari Hatting, and our audio editor, Jacob Fine.
Also to Mark Allnut for music production, Michal Wurchek for photography, Carl Jones for astrophotography, Susie Karras for graphic design. Thanks to Emil Mainkies for video creation, and to Moses Makungo and Abigail Thamaran for transcription.
We gratefully acknowledge support from the South African National Research Foundation, the Square Kilometre Array Observatory, the South African Agency for Science and Technology Advancement, the South African Astronomical Observatory, and the University of Cape Town Astronomy Department.
You can subscribe to The Cosmic Savannah on Apple Podcasts, Spotify, or wherever you get your podcasts, and we'd really appreciate it if you could rate and review us and recommend us to a friend.
And we'll speak to you next time on The Cosmic Savannah.